Hello, in this tutorial, we will look at how to create this landscape mountain using a lofted surface as well as constructing a road around it. We're going to look into how change the curve quality so the mount looks different. We're going to also look at how to change height of the peak. So this is something we could certainly adjust. We're going to look at properties such as how much the road is offsetting from the mountain, as well as thickness of the road. We can take a look at also how to control the position of this car along this using a slider. We will look at some other properties such as changing the scale of the car as well as the overall height. And then lastly, we will look at, for instance, property creating line types such as dash line, as well as changing or adjusting the color of all of this going forward. So in this case, in this short definition, we look at how to do a number of different properties, and all of that teaches us more about curve and surface operations. And we're going to create new from template. We're going to work with small objects feet. And I'm going to maximize my window to perspective window. And we will proceed from here. And I'm going to create a new layer. And let's call that, double click on it to change the layer. Let's call that landscape boundary curve. And I'm going to activate that. And we'll see if we need any other layers going forward. So let's go to, so first thing we do, we're going to draw a boundary curve here. So under curve freeform, there's a few different ways of creating curves that we can work with. So the first one called control points. And it is basically a basic NURBS curve. Here we can determine the degree. You could see that by default, the degree of the curve is set to 3. So I'll talk about degrees a little bit more as soon as we draw them. So then go to your perspective view and start placing your points. And you'll see that wherever you place your cursor, it's ultimately becoming a control point, and you can either snap to the end, make sure that you have your end object snap on, so this way you can snap. So just object snaps or both snaps, you can activate them from the space bar or whatever it's called. Or you can go to your command line and then click on close, and that way this becomes a closed curve. So these are my control points, and I'm able to visualize it this way. We're going to practice a little bit with this component, and we will try by slightly adjusting the degrees. So let's go back to the same command. So I can either in command line enter, and you'll see that I get the same item. And right now click on degree, and instead of 3, let's enter 1. Enter. So we're going to generally click around the same area. I don't recall, you can see that basically a 1 degree curve is a polyline. And that is because it only requires 1 control point to adjust the curvature, versus for a 3 degree, you need 3 different control points. And that's based on the diagram. So again, here I can go to close this. So now this is a 3 degree curve. This is a 1 degree curve. So let's continue. Let's continue using the same command, or here I can go to my icons on the left. And if you look at this icon here, the first one, if you do left click, will access the NURBS curve. And instead of 1 degree, let's change that to, let's say, 5 degree. And let's try to generally click around the same area. You'll see that basically a 5 degree is a much looser curve, because in this case, basically you need 4 control points to control the shape, and then let's go ahead and also click on close, and there it is. So these are basically multiple curves. So a 1-degree curve, a 3-degree curve, and a 5-degree curve. So 2 degrees, so even numbers are also possible. They're in between. So let's just try it for now if you like. So I'm going to use the same thing right now. Let's change that to 2 degree and generally click around the same. So it's a little bit more controlled than a 3 degree. Although I would say that by default geometry in Rhino is 3 degrees. So it's going to be rare where you're going to be working with 2 degrees. So 2 degrees are by default set up for geometry such as circles, such as ellipses, but it's also possible to adjust the degree. We'll talk about more degrees once we get into Grasshopper as well. So right now you'll see that I have a number of different curves. Definitely this is not something that I want to proceed. So I would say let's go ahead and select these and we're going to delete. So this is our first exercise that we just did it for practice. Now, if I go back to curve and freeform, the second option is interpolate points. So this one, you have a little bit more control, is where you click on actually your curve goes through. So you still have a 3-degree curve, as you could see. So if I change that to 1 degree, you'll see that that changed. If I change that to 2 degrees, you'll see that it's a little bit maybe in between, but the default in Rhino nerves, it's set up to 3 degrees, right? So let's go ahead and generally adjust. So again, I can snap to this or I can close. So this is my general geometry I'm working with. And at any point you could, adjust the property if you like. And this is our starting point. So we're going to actually build what we're creating in as this landscape, just the mountain part here, just so we're getting comfortable with the process. So the first thing is let's create a new layer. So just activate here, and we're going to click here to name, or you can always right click to rename. And let's call this extruded surface. And make sure that's activated. So now we're going to go to our command line and start to type extrude. And you'll see that there's different ways that we could do the extrusion. And one of the options is to extrude curve to point. So click on this option. So select the curve and right click and enter. And you'll see that it is actually giving me the option to extrude, but it's a little bit difficult based on the view to know that what where I want to snap this to. So a couple of things. I'm going to change my view to also render view. You can see it a little bit better. You can go to shaded view. So for us to actually extrude this straight up, let's go to our front or right. So now you can actually have this extruded a little bit more directly. Here you can do two things. You can hold ortho. Here you can hold shift. So this way you can actually decide that you can extrude it one way or the other. Maybe it could be one-sided. I'm going to go back to perspective. So you'll see that now that's extruded this way. So it's generally going in this direction. That's not bad. But one thing I want to try again, I want to try to see if I can have the peak actually more centered. So in this case, what that means is I actually need to know exactly where I want to snap to. So I'm going to select this actually delete. And what we're going to do now, we're actually going to find a way to select the center. So I can use that point as a reference and perhaps I can move it up. So here we have number of items under analyze. And one of the menus is mass property, where we have options here such as mass properties, area, centroid. So here we can first just get the area. So I'm selecting this and you can see that it's giving me the area in the units that I'm working in. So in this case, it's in feet. Or I can go back here and under Analyze, Mass Properties again, it could give me the area centroid. And if I'm going to select the curve, you'll see that now it actually gives me this centroid point. So I'm going to select this and I'm going to right click on layer 3 and I'm going to change object layer and I'm going to then rename this. Let's call this landscape boundary centroid. So then we have 3 different elements here. So now select the centroid point and you can just move it up in Z direction. So you can either just drag and move it up, or you can left click on the arrow, in this case in Z direction. And let's enter a value such as, let's say 15. And 15 in this case means 15 feet, right? And you can move that up if you like it higher. And I could say, for instance, move this up another 5 feet, and there it is. So we're going to use that as a reference. So let's try the operation one more time. We're going to go back and I'm going to be on my extruded surface layer, and let's call this extrude curve to point. So select that option. Again, we're going to select the curve, right click or enter. Now I can snap into this. You just need to make sure that from your object snaps, you have your point option on. And now go ahead and just snap to the point. And there it is. So now that's right at the center. So we're going to do something similar in Grasshopper. And sometimes if you're not sure how to build a definition in Grasshopper, one thing you could do quickly is try to mock it up in Rhino, and then that gives you what you like to work on. We also have these extra layers, so we can go ahead and purge. And what purge will do, it will get rid of any extra layers we have or any extra layers that are empty. So right now we only have layers that we are using. Next thing is, let's go ahead and save this with the naming convention that I'm giving you on Canvas. So let's go to File and do Save. Okay, so right now we're going to continue and we're going to actually rebuild this process in Grasshopper, but we're going to reference this base curve so then we can adjust it and everything could adjust accordingly. So these are my Rhino geometry, and one thing we could do is we can either turn off or hide. One recommendation I have when you're working with this type of geometry that has both Rhino and Grasshopper, create a layer, and I'm going to call this Rhino geometry. And you can use that as a way to then dock your layers underneath. And then this way I can, for instance, turn these off and still the layer is there. And later on, we'll make a new layer called Grasshopper Geometry. Okay, great. So next thing we're going to do, let's go ahead and launch Grasshopper, which we could do that by going to the command line and press enter, or you can click on the icon and go ahead and open Grasshopper. We're going to close this help button. Then I'm going to just dock my Grasshopper window on the side and we will proceed. Okay, so we will follow the same process, which was creating a curve. And in this case, we will adjust the degrees of the curve, and then we will go ahead and extrude it to a point. So let's go to our curve tab, and under spline subtab, there's a number of different components we could use. So here we have Bezier curve, an interpolated curve, as well as a NURBS curve. So we can either use an interpolated curve or a NURBS curve, similar to what we constructed in Rhino earlier. For this exercise, let's go ahead and create a NURBS curve and drag and drop that on canvas. And you'll see that this component right now is orange. Orange means that it's still waiting for information. So what is the information it's looking for? If you hover over vertices, and vertices are points that make up a geometry, in this case, control points. It's waiting for a control point for us to give it, and then the degree, by default, this is set to 3. And then periodic or imperiodic, it means like whether it's an open or closed. So it looks like we need to provide vertices. So let's go back to our Rhino. So I'm going to double click on our taskbar here, and I'm going to turn on the boundary curve here. So if you recall, I just randomly clicked somewhere and it provided me these control points. So what I need to do is right now I can extract these control points, and then I can create a similar curve in Grasshopper. So, but the question is like, how do I extract these control points? So under curves and under surface, any geometry, there's a number of components for extracting information. So in this case, if we go to our command line and if you start to type extract, and you can see that there's many different ways of extracting geometry. There's different types of geometry. In this case, what I want to extract is extract points, in this case, control points. And you'll see that because I already had the curve selected, it's allowing me to extract. So it actually extracted these control points. So if I didn't have the curve selected, it would have just asked me to select the curve, right? So now I have these control points, which I'm going to use and reference in Grasshopper. Because I'm referencing this in Grasshopper, I'm going to make a new layer, and we're going to call this Grasshopper geometry. And this is a great way for you to separate what is constructed in Rhino and what is constructed in Grasshopper. And I'm going to create a sublayer here, and we're going to call that control points. Great, I'm going to place this as a sublayer, and then let's go ahead on control points. I'm going to make that an active layer and then start to select these 1, 2, 3. You can either select them one by one, or when you have a lot of points, if you go to your command line and do SEL, cell, you can do SELPT, select point. Then all the points are selected, right? So this is a great way for you to select. Then go ahead and right click and tell it to change object layer. And there it is. So now these are on that layer. Great. So now that I have this control point, I can go ahead and turn off the curve. Now let's go back and call our Grasshopper, which is right here. And now I can reference these points in order to create the vertices, right? So let's go ahead and grab a point container. So point container, we find them on the parameters under geometry point container, or if you double click on canvas, just type point. That will be the first thing that we can do. So they're both orange. It means that they're waiting for information. So let's go ahead and reference these. So we're going to right click. So in the tutorial 2.1, we saw how to reference singles. So when you're referencing, it's about whether you're referencing one or more than one. And more than one could be 2000, whether it's 2 or 2000, it doesn't matter, right? So set 1 point or set multiple points. In this case, we're going to do set multiple points and start to select them. Now, where we start to select the points is going to determine the start and end of our curve. So in this case, it really doesn't matter, but we'll visualize this and you'll see that actually how the decisions, such as what to click on first or second, it changes the way that our geometry is constructed. So just start selecting somewhere just try to select them in the order. Don't skip over an order because that's how our curve will be constructed. Then right click and then Here it is. These are referenced together. So first thing, I'm going to group this to itself, Control G. And then we're going to right click and we're going to see these are our referenced control points. Great. So now let's go ahead and reference these control points to vertices, and there it is. So you have your control point here. Now we also have the degree and periodic or aperiodic. So the degree could be either between 1 through 9 maximum, but by default this is set to 3. So let's make a slider that goes from 1 less than 5. You really more than 5 degree becomes very difficult to read the curve. 1 less than 5, enter. And let's connect that to degrees and we'll see that again like what we saw. 1 is a polyline, right? And then 2, 3, 4. So you see that as the number is increasing, the definition is changing. Then the other option is whether it's a periodic or aperiodic curve, so whether it's open or closed. So by default, this is set to false. If I right click, I can change this Boolean, but Regress software is explicit modeling, so it's best to use components to set this up. So let's go to our parameters under input, and we're going to look for this thing called a Boolean toggle. A Boolean toggle or a Boolean is something that's either true or false. So here you can double click to change that and connect that, and let's turn that to true. So you can see that now we have our curve closed. Great. So right now you see that now this is a closed curve. As I'm changing the degrees, the property is also changing. So let's also try another component here. So this is a NURBS curve, which is the same thing that we saw here. So the same first option here from control points, or from here, curve freeform from control points. And I'm going to just group this to itself, Control G. And this is going to be our NURBS curves. Then let's go back to our parameters, curve, and under spline, let's look for an interpolate. And you'll see that the setup is on the same, except for this other option for creating knots. We'll talk about knots later on, but let's try to provide the same input. So right now we're providing the vertices. You'll see that with interpolated curve, it actually goes through the curve. Then the degree is the same, so it's 3 degree. And then the toggle, whether it's periodic or aperiodic, right? So we see that that's the start and end. So even with an interpolate, I can determine. So basically a 1 degree curve, whether it's 1 or not, because they're actually going through it, it's the same. But then when you're starting to change the degrees is when you're starting to change that, right? Great. So I wanted to show you these 2 different types. For this tutorial, I think interpolated curve will be a little bit better. It really doesn't matter. I think we can try at the end. We can just swap this. So I'm going to also group this to itself, Control G. And here we're going to call that interpolated, right? Actually, let's make this singular, interpolated curve, and NURBS curve. Okay, great. So we have our curve. I'm going to go ahead and turn off our NURBS curve. You can right click right in the cloud and then turn this off, or remember the shortcut was Control Q, where you can turn this on and off. Okay, so we will continue from here. So the next thing for us is to find the centroid of the interpolated curve. And we did that in Rhino by going to Analyze, go to Mass Properties, and finding Area. If you're not sure where to look for it, because that actually doesn't exist under Curve Analyze to finding the area centroid, sometimes curve and surfaces share certain components together because they're working with basically closed boundaries. So under surface, under analysis is where we will find the area and component. So if you go under surface analysis area, drag and drop that, and you'll see that it is basically taking BREP, which stands for boundary representation, or it's the same as polysurface, mesh, or planar closed curve for area computation. So in this case, we're going to provide the curve as input, and it's going to give us two different information. One is the area, and then the other one is the centroid point, right? So that's the point we're looking at here. That's the point that is being highlighted. So let's do a couple of things. We're going to move this point up. So moving is a type of transform. So under transform, under Euclidean, let's find a move component. And it's asking for geometry that we want to move. So in this case, what I want to move is this point. So this centroid point, we're going to provide that as the geometry, and you'll see that it actually moved it up. So by default, it has a vector for moving this up. So the vector has 10 values. So this is moving up 10 values. So we're going to actually adjust that. First, we're going to go to our vector tab, and under this vector submenu, you'll see that there's basically set up unit-based vector. So, and if you think about what a vector is, vector has direction and amplitude, right? So the direction is in z direction, and then we need to provide amount. So let's grab a unit z. So if I just connect it as is, and you can see that this one doesn't have a preview color because it just provides value. This is a unitized vector. Basically, it is only doing one value. So unitized or parameterized geometry or vectors are only working with, so it's less about the amount, but more about that. And then the next thing is the amplitude. So we're going to make a slider that's going to go from 1 less than 20 less than 40, 1 less than 20 less than 40, and then let's give it 1 point decimal, enter. And we're going to provide that as the vector input. And there it is. So now we have our point that's moving up and down. Great. So before we go forward, we're going to clean this up a little bit. We're going to go to the beginning. These are the reference points, and we're going to select, and you can right click or control Q to turn off the preview. Then I'm going to go back to Rhino, and also I'm going to turn off these control points. I'll go to the parent layer and then turn that off. So now I don't need to see that. Great. And then the next thing is we're going to do some grouping and naming here. So we're going to select the area component, and we're going to say this is going to allow us to extract area centroid. And then we're going to move this up, right? So we extract the point and then we move it up. So therefore, this is a duplicate, right? So this is the original, and then this is moving it up. So this is ultimately the height of the peak. I'm gonna group this to itself, and so move 10. Okay, so we have everything set up. Now we need to just create basically an extrusion from here to the point. So let's go to our surface tab and under freeform. So we'll see that what the options are in this case. So you'll see that there is an option here. It says extrude to a point. So the icons are very, very helpful. Extrude curves and surfaces to a point. So we can also extrude surfaces to a point. So grab this and place it here. So the icon also tells us what it's doing. So it's asking for a base curve. So our base curve is coming from our interpolate component. So I'm going to drag our curve output to the base, because base could be a curve or a surface, so provided here. Then it's asking for a point. So this is the point that we just moved up. So then provide the point geometry, and there it is. So we're able to now adjust that. So what you're looking at here, this is the seam of your surface. The seam starts here because also with our points, this is where our points are starting and ending. So there's a few other things we can adjust here. There's also our degree of the curve. So if I turn this into 1 degree, you'll see that that becomes basically a polyline, right? And then let's go back to our Rhino and turn on our boundary curve. So let's switch this back to, let's turn on our control points, and that's what's basically determining that. So if you start to move the control points, of course, the mountain will also be moving. So maybe we can do something like that. So just play with that a little bit. And of course, we could make this maybe more fluid, 2 or 3 degree. So there it is. Okay, great. Once you like the shape, let's turn off the control points again, and let's proceed. So I'm going to then group all of this together. So this is basically what gives us this landscape. And I'm going to do Control G. And I'm going to, instead of anything, I'm going to right click and change the background of this. I'm going to right click and change the background of this group. So then this way I know that, okay, this is a specific thing, but I'll keep this specific color for my components. And I'm going to say this is my landscape. This is my landscape surface. The next thing we will do is, now we have this extrusion, but if you look at it, this looks like basically an open surface. So we're going to go ahead and actually make this a closed geometry. So let's go to our surface, and under utilities, this is where we have some options for repairing or fixing our surfaces. And one of the options here is an option called cap holes. Cap holes, basically when you have an open surface or a poly surface, you could, when you have an open poly surface, you can fix it. So under surface utilities, do cap holes and connect the extrusion here. And now that becomes a closed surface, right? So let's take a look at what happens before and after. So let's grab a panel, double click, quotation mark, enter. So before I close this, this is called an untrimmed surface, right? Because basically this is a surface that's wrapping around, and that's the seam. But as soon as I cap this, it's telling me that it's a closed BREP. So BREP, which stands for boundary representation. Equivalent of that is a polysurface or a solid in Rhino. Great, so now this is a solid geometry. And last thing, we're going to also apply a custom preview to this, which we did in our last tutorial. Let's go to display. Let's go to our preview component, grab a custom preview and connect your geometry. And then we're going to also apply color to this. So go to our parameters, under input, grab color swatch and connect that. I'm going to give it, like, let's say, I'm going to change the color, like maybe a greenish, say a greenish color, and there it is. And we can change that as we see fit. Then a couple of other housekeeping thing. I'm going to group this as part, add this as part of the group. So select these, right click and add to group. And then I'm going to turn off the preview of whatever I don't need. So if you recall, what is darker, this preview is off. What's a little bit lighter, it's on. So you can select, or you can even window over everything. So everything except for custom preview. So you can just window over it. And if you use your middle mouse button, you can tell it whatever I'm selecting, preview off, right? So this way you can do that. Or you can do that one by one or just window over that, right? That's our setup. So the next thing we're going to do is we're going to take our curve. So this is the curve that we had, and we're going to create an offset. So offsetting is a way where we can take our curvature and then we could create kind of adjacencies based on that. So if you go to curve utilities, you'll see that there's multiple different types of offset we could do. So one of the ones that I think will work well is called offset curve loose. What I like about this versus this more strict offset is that this would be basically your curvature will resemble more of the road. So let's go to offset curve loose, drag and drop that here. So it's asking for a curve and then offsetting distance. Go ahead and connect your curve output to the curve input. And you'll see that it is actually giving you that offset, which is predetermined by this distance, which is 1. So let's go ahead and create an offset here. So this is the first offset where imagine your road usually has a little bit of a distance from the edge. So we're going to create a slider that goes from, let's say, 0.5 less than 5, enter. So use that as an offset. So this is your kind of distance of the road from that. And then this is if your offset is happening on a different plane. In this case, everything I'm doing is on XY plane, so that should be more than fine. So let's go back to this. So this is the distance from the edge. And now we're going to do one other offset. And we're going to either select this or double click and go look for offset loose curve. And now this time we're going to then provide this second, the offsetted from the edge again. And then let's do this one more time. And then we're going to import another value. Let's enter in this case, because this is width of that. We're working in feet, so let's do 5 less than 30. Then that's our width of the road, right? So you will see that there's, because of the curvature, some areas are more offsetted, but this actually works if you're designing a landscape. So if the turn is more extreme, you actually have more width. We will look at other offsetting methods in our later videos. So for now, this certainly works. And then let's go ahead and group the first one, Control G, and this is going to be our edge of the road, the mountain. And then this one is going to be Control G. This is going to be road width. Great. So next thing for us is to actually create a surface between these. So these are two planar curves. So let's go ahead and go to our surface tab under freeform. You're going to look for a component called boundary surface. It says create planar surface from a collection of boundary edge curves. So do that. So in this case, if I connect one of these, you'll see that it actually creates a planar surface. But if I am connecting two, which we do that by holding down Shift and connect the second one, you'll see that it actually gives me the in between. So then this way, I'm able to connect both. Just make sure that you're hold down Shift when you connect the second one. If you don't, by default, Grasshopper only takes one. So I'm going to disconnect. If you recall, we can do that by holding down Control and disconnect. Or And then let's connect again. So connect the first one, and then hold down Shift when you get this plus sign, then connect again. Great. So this is going to be Control G. This is going to be our road surface. So next thing we're going to get an mean curve or the average curve. So that can be, let's say, the midway between. So we're going to go to our surface, our curve under spline, and we're going to look for a component called tween curve. Tween curve or mean curve, it gives you the average, right? So the first curve that we want to use, this is basically the offset curve. So connect that as curve A, then connect the second one as curve B, and now we have this curve that's the average. So this is the factor. So there is right now it's set up to 0.5, so it's midway. So curve A is considered 0, curve 2 is 1, and this is in between. So let's grab a slider under parameters input. I'm going to use a default slider because default slider is between 0 to 5. So 0.25 is actually going to be quarter of the way, but it's closer. So you'll see that this way, basically this distance, and a lot of the variables in Grasshopper by default are parameterized, meaning they're mapped to be between 0 and 1. So right now, if I want this to be midpoint, just double click and make this 0.5. Great. So then this way, I'm going to move this here a little bit. Next thing we're going to do is we're going to make this into a dashed line. So it looks like it's actually your guidelines. So if we go back to our curve under division, we have a lot of different ways to divide or stylize curves. So under curve division dash pattern, I'm going to connect the curve input here. And it's looking for a pattern, which is basically the gap. Think about that like in an Illustrator. So I can just make a copy of this slider here, Control C, Control V, just to see what it looks like. And I'm going to turn off the tween curve. So select or Control Q, and you'll see that actually this is my dash line right now that I'm able to set up. Great. So that looks like actually a road that we've set up. So let's group this to itself and say this is your mean or your average or mid curve. And then this is your creating these patterns. Okay, so we have basically our road, and the last thing is for us to apply color to these. I'm going to do two color, one for a surface, one for the dashed line. So I already have my custom preview and color swatch here, or we can go to display again, grab a custom preview, and we're going to put that next to our road surface. So connect the road surface. And let's get a color swatch. And you'll see that over time, basically this lower left icon is suggesting you, if you start to always use a color swatch after your custom preview, it will start to suggest. So I can just drag in from here, or you can either double click on canvas and search for it or grab it from here. So I'm going to make the road color maybe a darker color here. And then I'm going to actually add this. I'm going to actually copy this. And you see that it's already connected, right? But because it only takes one input at a time, you can easily just connect it. I'm going to make this yellowish color so it looks like the road. Then I'll go ahead and add this to the group. I wanted them to be the same, and then add this to the group. Great, so we have our road. So going to just group this, all of them together as well. Going to change the background color for this. And you can just play to see what color you like, just so like I know they're a different operation. And then this is our road geometry. Great, so we have the mountain, we have the road, and now I think it's a good time to save our definition. So go to Canvas and take a look at the naming convention that we have, which is your first name, last name, underscore tutorial, underscore M 2.1. So go ahead and save your document. So I'm going to save my document at my first name, last name, underscore tutorial, underscore M 2.1.gh. And then I'll use the same for my Rhino. Again, it's always good convention to give your Rhino and Grasshopper file the same name so then you could actually track them and find them. Great, you have our mountain, we have our curve, and the next thing we're going to do is to then start to create a car and then create the parametric relationship between them. Okay, so next thing for us is to create the car, and in this case, car is going to be represented by a box. So a box, which is a type of surface, and if you go to primitive, you'll see that there's different ways of constructing boxes. So it could be from, let's say, 2 points, or we can provide X, Y, and Z. In this case, I'm going to use a center box and drag and drop a center box here. And I'm going to momentarily turn off my landscape so you could see what this is. You don't have to do that. You can just watch what I'm doing. So I'm going to right click and turn off, or Control Q. So a center box is a box, or a center geometry is a geometry that's created from the midpoint, right, from the centroid. And what you're looking at here is a base plane, So just like vectors that have basically a direction and amplitude, we are working with planes that are following these two directional unitized vectors that are allowing us to understand orientation and how geometry works. So by default, base planes are set up to the origin, and a plane requires an origin, right? So start point, and it requires two vectors in X direction and in Y direction. And it has this preview where you might be seeing it in a different scale. So if you go to your display menu here, there's an option that says preview plane size. This is by default set to 8. You could change that to, let's say I'm going to change it to 4. You just have to enter while you have the box activated, and that changes the plane. And planes are a way for us to be able to position our geometry how we like. So if you hover over it, you'll see that it says in X direction. So this is our X direction. It takes 1, but it actually takes 1 plus 1 minus, right? Because it's center geometry. So let's just grab our standard number slider. And if I start to provide X, you'll see that, yes, that's basically from the center, it's growing. And then if I do the same thing for Y, as you can imagine, and if I do the same thing for Z. So in this case, the car that we're creating, I want it to be a little bit larger in X direction. So let's do something like, I'm going to double click and do, let's say 0.9. And then in Y direction, let's do something like 0.6. We can certainly adjust this. And then in Z direction, this is height of the car. Let's do something like 0.8, right? So hypothetical car that we have. So that's our first step, and it's certainly working. But you'll see that actually what it does is it's creating this from the origin. So we will fix this later on. So this has a plane, and what I want to do is I want to transfer this on this road. So I need to find a way that I can align this. And also this needs to start to go in the correct direction. So there's many different ways we could do this, and the simplest way that I can explain how planes work on the curves, if we go to our curves tab and under division, you'll see that there's many different components for us to work with planes or extracting planes from curves, or under analysis, there's also a number of different ways for us to extract planes. So the component that we're going to be using for us we're going to use a component called curve frame. It says get the curvature frame of a curve at a specific parameter, right? At a specific parameter. So that could be anywhere along. And again, there's many different ways we can do this. Right now, I'm showing you the way that I can explain what's relevant to this tutorial. So on the curve analysis, let's grab curve frame. And if we hover over it, it says that in any point, I can actually extract a frame. So that's the curve, and that's the parameter. So what's the curve that I want to use? I'm going to move this a little bit over. In this case, the curve that I want to use is the midpoint, right? This tween curve. So select, attach the tween curve to the curve input, and then it's asking for a parameter. And as I said, by default, a lot of the values in Grasshopper are parameterized, meaning they're mapped between 0 and 1. So let's just try to provide a slider that goes from 0 and 1, our standard slider. And you'll see that as soon as I do that, and we create a plane. And for a moment, I'm going to turn off the preview here so you could see it better. This is a little bit better. So if I go to 0, in this case, for the frame, this is right now the beginning, and it should technically move forward, right? But you could see that it's just barely moving. It's barely moving here. It looks like it's going along, but it's barely moving. The reason is that actually, it although by default, a lot of the curves are mapped between 0 and 1, but that's not the case here. So a lot of our variables, anytime that usually you're working with curves, etc., you have options if you right-click. So there's a number of options here where we can get into. And this is where in the next section, we're going to look at a lot of ways of changing or modifying your data. So anytime that you're working with curves, if you right-click, there should be an option to reparameterize. And reparameterization, as you look at the icon, it looks like it's a curve that you're rescaling or pushing to meet it. What that means is whatever the length of the curve is, you're going to remap it between 0 and 1. And why is that useful? Because then you don't need to worry about adjusting your parameters. You can always just assume that it's between 0 and 1. So let's try that. You'll see that you're now have that icon. And then if I try it right now, you'll see that actually with the same slider 0 and 1, it goes all the way around, right? And it really doesn't matter what the length is, because here, if I change my mind, if I'm scaling it up, so of course, if it's scaling it up, the length is changing, right? But if I uncheck this, again, 0 literally means 0 and 1 means 1 feet. So it's only moving 1 feet. But as soon as I parameterize the curve, 0 means the start and 1 means the end, meaning 0.5. If I want to say what is the midway, that's right there. So it's a wonderful way for us to adjust our geometry parameters by talking about mainly relationships versus, specifics of the land. And there's definitely cases where I want to be very specific that I'm moving specific distance, but sometimes you just want to look at the relationship, right? So between 0 and 1. So I'm going to park this at 0 and let's proceed. So now that we have this frame, I can use this frame as the reference frame for us to recreate the car. So let's provide this frame as the base frame. And plane and frame they could be used interchangeably. depending on the circumstance. So when we're working with curves, these are called frames. And then when we're working with a standalone, then we're talking about this as planes. So provide this as there, and there it is. So you'll see that now if I move this, your box, your car is moving along. Now, if I don't want to see the preview, this is basically extracted from here, so we can just turn off the preview. Great, so it looks like right now everything is working. The only thing is that because this is a center box, this half of the car is actually below the surface. So we're going to move it up based on this value, because if you recall, this value is plus and minus because this is a center box. So let's grab another move component, which we're going to do by going to our transform tab and then under Euclidean, grab a move. And I'm going to move this box up by how much? By that amount, right? So then it's going to be on the surface. So I need, first I need to grab a unit Z. So we're going to go to our vector tab, vector unit Z, or if you double click and just type Z, it's going to give you a unit Z. So that's the box, which is the geometry. By default, it has a vector of 10, so it moves it up. But I'm going to replace that by this amount, right? So whatever that is, there you go. So now it's sitting on the surface. So I'm going to turn this off because this is the previous one. Now we have our geometry that's just floating on the surface. So you can basically drive your car. So let's just look at this from the top just to verify our frame. So you'll see that you're moving this along and it's moving along the curve, right? It's taking the direction of the curve or your t value, so the tangent vector, and we're going to talk about specifics of the tangent vector. That's the vector that's going along your curve, and it's extracting the tangent vector in order for us to move around. So great thing about components like that is that it's already doing a lot of the calculation for you, but we're going to look at cases in the future that we actually have to extract the tangent vector ourselves. So that's what it's showing us here. Okay, let's go ahead and turn off this. So I'm also going to do some grouping and custom preview. So we're going to add custom preview to our car. So I can just select these and do Control C, Control V. At some point, if you need to repeat the same thing over and over again, you don't need to recreate it. And I'm going to give it maybe an orange color, orange red color. And then let's do some grouping. I'm going to go from the beginning. So I'm going to group this to itself. And this is, we're going to say extract tangent frame along curve. And then this is basically all of this is our Control G. We're going to call that our car geometry, our car geometry. And then this is our Control G, say preview car. And I'm going to group these together, this part, Control G, and then I'm going to change the color of the background to something that's maybe a little bit more green, so it looks different. And then I'm going to this, and then we're going to call this along mid. Okay, so last thing, let's just leave the preview, the final previews on. So let's turn off the dash. So anything that's basically has this light color, we can turn off. So we said that the grasshopper, one thing that's really great, it gives you the preview. So for instance, I'm going to turn off these, so select, and you can do Control Q. And then all I need to turn on is the preview here. So over time, as I'm doing, you will decide whatever is the shortest way. And then we also have our landscape. Maybe I change the color of landscape a little bit. More green this way. And just remember that we have so many parametric options here. Here, the entire curve changes, right? Depending on the degree. Let's keep this at 3. Here, the height of the mountain changes. So just pick a height that you like. You can change the color. Here, the distance from the landscape changes. Here, the width of the road changes. And you always have the midpoint. We can decide where that kind of traffic line is. Let's keep it at 0.5. I think it's going to preview better. We can change the spacing of this. If you like to increase this, you could right click and go to values here, or you can go to edit and you can double click, maybe select a larger number and commit changes, and that would allow you to have more. Here, maybe we'll do 1.5 for this. That looks great. And then, of course, the size of the car. So let me rotate and look at it here. So if we want to increase this, we just need to increase the value here. Again, right click and go to edit or value, and let's scale that up to 2. And of course, if we were doing this, precisely, so this is about 2 meters, maybe that's quite small for a car. You can make this, so you can go to edit or you can go to value, and at any point you can drag up or change. Same thing with the width. So right click, go to value, and let's move this up to 2. So just find something that you like. I think the height as well, we can go to maybe something like 2 here as well. And this is kind of a diagram of a car, right? But just select the number that you like fit, select the color that you like fit. And then last thing, let's go back to Rhino. And remember that everything that we have, it basically is coming from these control points. So you can also adjust your control points a little bit. And you'll see that like how quickly everything in your geometry is responding to this. And yeah, so we have our first parametric basically composition here. And with this, you're starting to learn more about curve properties and planes. And we're going to continue these in our next tutorial. I'm going to make sure that I turn this off, where we will delve more into properties of geometry, single versus multiple, and then we go from there. So just make sure that you save your both Rhino and Grasshopper and submit it on Canvas. Thank you, and hope you enjoyed this tutorial.